You know, they were talking about climate change yesterday, and now we're learning that scientists and researchers are looking at how to change the weather on purpose. That's right. Lasers now could one day manipulate rain and lightning. CBS This Morning contributor Michio Kaku is a physics professor at City College of New York. Professor, nice to see you. Extraordinary seeing Al Gore and Bill Clinton there together with Charlie, wasn't it?
That's right, yeah.
Yeah, they did not get into this discussion, though. But it is fascinating. I mean, lasers, really, to change the weather?
That's right. Well, as Mark Twain once famously said, everyone complains about the weather, but no one ever does anything about it. Well, instead of doing a rain dance, we physicists are firing trillion-watt lasers into the sky to actually precipitate rain clouds and actually bring down lightning bolts. This is potentially a game changer.
But this is experimental.
It's experimental. However, in the laboratory so far it works. When you have water vapor and you have dust particles or ice crystals, you can precipitate rain. It condenses around the seeds. These seeds can also be created by laser beams. By firing trillion-watt lasers, you rip apart the electrons, creating what are called ions, and these ions act like seeds, like dust particles, bringing down rain and even lightning.
Go ahead.
Well, this fascinates me in part because, too, I remember reading the stories that China had used this during the Olympics, that the USSR had used this after Chernobyl to create rain clouds. I mean, did those really work then? We have some of these capabilities now?
Inconclusive. Even in the 60s, the CIA used this to bring down monsoons during the Vietnam War, to wash out the Viet Cong. Governments have been playing with this thing.
Alleged to.
Alleged to, right.
Yeah.
Now, we realize that for decades now, these governments have been alleged to have experimented with weather control, but nothing conclusive. This time we're bringing in the laws of physics rather than simply waving our hands and uttering mumbo jumbo. We're actually using trillion-watt lasers now. And in the laboratory, sure enough, they precipitate rain out of water vapor. Sure enough, you can actually bring down electricity down the beam.
So what does it mean for drought areas that need to have rain for crops? And if they don't have them, there's the consequences of famine.
Well, the bad news is if it's a clear blue sky, it's not going to do anything at all, because it only takes water vapor that's already in the air and condenses it. However, for floods, for agriculture, farmers, for people planning wedding parties, football games, you name it, outdoor events and agriculture and flooding and even hurricanes, all of them could be subject to weather modification.
Incredibly interesting, Professor Michio Kaku. Thank you so much.
Mr. President, honored delegates, ladies and gentlemen, we shall propose further cooperative efforts between all the nations in weather prediction and eventually in weather control.
Remarks the President to the National Academy of Science from Constitution Hall in Washington, D.C., October 22, 1963.
And third, there is the atmosphere itself, the atmosphere in which we live and breathe and which makes life on this planet possible. Scientists have studied the atmosphere for many decades, but its problems continue to defy us. The reasons for our limited progress are obvious. Weather cannot be easily reproduced and observed in the laboratory. It must therefore be studied in all of its violence wherever it has its way. Here is an oceanography. New scientific tools have become available with modern computers, rockets, and satellites. The time is ripe to harness a variety of disciplines for a concerted attack. And even more than oceanography, the atmospheric sciences require worldwide observation and hence international cooperation. Some of our most successful international efforts have involved the study of the atmosphere. We all know that the World Meteorological Organization has been effective in this field. It is now developing a worldwide weather system to which nations the world over can make their contribution. Such cooperative undertakings can challenge the world's best efforts for decades to come. And fourth, I would mention a problem which I know has greatly concerned many of you. That is our responsibility to control the effects of our own scientific experiments. For as science investigates the natural environment, it also modifies it. and that modification may have incalculable consequences for evil as well as for good. In the past, the problem of conservation has been mainly the problem of human waste, of natural resources, of their destruction. But science has the power for the first time in history now to undertake experiments with premeditation which can irreversibly alter our biological and physical environment on a global scale. The problem is difficult because it is hard to know in advance whether the cumulative effects of a particular experiment will help or harm mankind. In the case of nuclear testing, the world is satisfied that radioactive contamination involves unnecessary risks, and we are all heartened that more than 100 nations have joined to outlaw testing in environments where the effects most directly threaten mankind. In other fields, we may be less sure. We must, for example, balance the gains of weather modification against the hazards of protracted drought or storm. The government has the clear responsibility to weigh the importance of large-scale experiments to the advance of knowledge or to national security against the possibility of adverse and destructive effects. The scientific community must assist the government in arriving at rational judgments and interpreting these issues to the public. To deal with this problem, we have worked out formal procedures within the government to assure expert review before potentially risky experiments are undertaken. And we will make every effort to publish the data needed to permit open examination and discussion of proposed experiments by the scientific community before they are authorized. If science is to press ahead in the four fields that I have mentioned, if it is to continue to grow in effectiveness and productivity, our society must provide scientific inquiry the necessary means of sustenance. We must, in short, support it. Military and space needs, for example, offer little justification for much work in what Joseph Henry called abstract science. Though such fundamental inquiry is essential to the future technological vitality of industry and government alike, it is usually more difficult to comprehend than applied activity, and as a consequence, often seems harder to justify to the Congress, to the executive branch, and to the people. But if basic research is to be properly regarded, it must be better understood. I ask you to reflect on this problem and on the means by which, in the years to come, our society can assure continuing backing to fundamental research in the life sciences, the physical sciences, the social sciences, on natural resources, on agriculture, on protection against pollution and erosion. Together, the scientific community, the government, industry, and education must work out the way to nourish American science in all its power and vitality. Even this year, we have already seen in the first actions of the House of Representatives some failure of support for important areas of research which must depend on the national government. I'm hopeful that the Senate of the United States will restore these funds. What it needs, of course, is a wider understanding by the country as a whole of the value of this work, which has been so sustained by so many of you. I would not close, however, on a gloomy note, for ours is a century of scientific conquest and scientific triumph. If scientific discovery has not been an unalloyed blessing, if it has only conferred on mankind the power, not only to create, but also to annihilate, it has at the same time provided humanity with a supreme challenge and a supreme testing. If the challenge and the testing are too much for humanity, then we're all doomed. But I believe that the future can be bright, and I believe it can be certain. Man is still the master of his own fate, and I believe that the power of science and the responsibility of science have offered mankind a new opportunity, not only for intellectual growth, but for moral discipline, not only for the acquisition of knowledge, but for the strengthening of our nerve and our will. We are bound to grope for a time as we grapple with problems without precedent in human history. But wisdom is the child of experience. In the years since man unlocked the power stored within the atom, the world has made progress, halting but effective, towards bringing that power under human control.
And as a result, I think the people in the Congress are going to support it. And that message calls for new frontiers, new vision. It calls for us taking the steps now that will make us no longer second in space and in science. It lays the predicate and the foundation for a space communication satellite that will permit the people of the world to see one television program at the same time throughout the world. Think about that kind of communication and think about the opportunity that will provide. It lays the predicate and the foundation for the development of a weather satellite that will permit man to determine the world's cloud layer and ultimately to control the weather, and he who controls the weather will control the world. It lays the predicate for the steps that are necessary to send a man to the moon.
In 1962, the U.S. government launched Project Storm Fury, which aimed to hack hurricanes by seeding them with a chemical that would remove their moisture. Over the course of a decade, Navy pilots set out for the skies directly above a series of hurricanes and sprayed a substance called silver iodide into them, believing it would turn the supercooled water inside the storm into ice, which would then fall out of the clouds in the form of hail. With the moisture removed from the clouds around the eye wall, it was thought they would grow faster and steal the warm air that had been feeding the eye, thereby choking it to death. Or so Storm Fury's scientists hoped. Dr. Hugh Willoughby was one of them.
Out of the 8 attempts, there seemed to be 4 successes. The landmark experiment was in Hurricane Debby in 1969, where they attempted to seed the storm twice, and both times it weakened after they seeded.